Hey, what's up everybody? How have you been? Today I'm going to make this video on how a computer program actually runs. Can you please explain how the electricity going through the computer turns into code and how code turns into electricity? That would be awesome. First of all, this is an insane question. There's so much stuff that happens in between code and electricity that it's just... Answering something like this would probably take a full college curriculum in computer systems and computer science, or plan B is to watch me explain it to you on YouTube. So, alright, so in this video we're going to trace the life cycle of a really simple computer program and how it runs through your computer from start to finish. The only job of this program is to print hello on the screen. We're going to start from the time a computer programmer writes this thing to when it finishes executing on the computer and you see that message. There's going to be a ton of stuff that's going on in this video, and everything is really big picture ideas. If anything I say or any word I mention doesn't quite make sense to you, just pause the video and go to the library, Google, and look up that word. Alright? Let's do it. Alright, first of all, just check out this program right here. And it starts out its life as just a simple source file. A real person, not a robot, went to their computer and typed this. Once they're finished writing this program, they'll save it using their favorite editor, and this source file is going to be saved on your computer. This file itself is just a sequence of ones and zeros which represent all the text values that you just typed in on the keyboard. Literally, the bits represent the pound sign, I, N, C, L. Alright, so quick aside on files, bits, bytes, and all that jazz. Bits are organized into 8-bit chunks called bytes. A file is literally just a sequence of bytes. Nothing more, nothing less. In fact, everything you can think of is represented by bytes. From files to programs running in memory to data flowing across the network, everything is ones and zeros. The only thing that distinguishes different data is the context in which we view them. In different contexts, the same exact sequence of ones and zeros could mean a string, a number, or it could even mean a really intricate machine instruction. It's just a matter of perspective and context. So in the code source file that we just wrote, each byte has a value that actually represents a text character like A, B, C, D. Usually when the characters in a file are human readable, like you or me could read them, we call those text files. In all other files which aren't really human readable, we call those binary files, and if we open them up, you would have no idea what they're doing just by looking at them. Right now, the hello file is a source file because some human wrote it and we can read it, but that's not the type of file that a computer would understand. Now we have to use other programs whose job it is to translate source files into machine understandable files, otherwise known as machine level code. This whole process, which I'm kind of glossing over, is called compilation. What compilation essentially does is translate human readable files to machine level instructions. It then usually packages up those instructions into another file, which is called an executable file, or a lot of people just call them executables for short. Once the compilation is done, it usually saves this executable file somewhere onto our computer. Remember, this executable file is on disk right now. It's not in memory, it's not in RAM, and we haven't run it yet. All we've done is do this translation part, and now we need some way to execute this program. Alright, so we have an executable, so how do we run it? One way to execute a program is to use another program, which is called a shell. If you don't know what a shell is right now, just Google it real quick. It's the matrix-like thing where you type and magic happens. The shell is actually another computer program written by another programmer, and it's a command line interpreter. There's a cool line, a command line, which prompts you to type in things. Once you type in special commands, this shell interprets them and executes them for you. Pretty simple, right? There are a bunch of built-in default shell commands that do really cool things. If you type something into the shell and it's not one of its built-in commands that it already knows, it assumes you're typing in a custom executable file that you want to execute. Now there's going to be a lot of crazy hardware details that are going to come into play. The shell program interacts a little bit with the keyboard, so it knows how to parse your keystrokes and display them for you. Also, the program exists on your disk right now, so you know that in order for it to be run by the processor, it needs to be moved into memory, and there's also special hardware to do that. So we have an executable file which is called hello, for example, and we're going to type hello into the shell and press enter. We physically press enter with our finger. Okay, let's take a quick step back. Remember how I told you processors are really dumb but powerful? A processor pretty much executes instruction blindly. It just does what it's told. So how does the processor know what instructions to execute at any point in time? This part is managed by the operating system. Remember, at any one point in time, you have a lot of processes running on your computer, and the operating system is managing them. It's also telling the processor which process it has to run at any point in time. Alright, now this is a really important point to try to digest. When a process is running on your computer, the operating system gives it the illusion that it's the only process that's running. So if the computer is one big house, the operating system gives each process the idea that it's the only one in that house. It has exclusive use of the processor, it has exclusive use of the memory and other resources. In reality though, we know that this isn't the case. There's tons of processes running at any point in time. Okay, so major takeaway from that is that when a process runs, the OS is really smart enough to give that one process the illusion that it's the only guy in the house. Alright, now let's go back to our shell program and what we're trying to run, which is this simple hello executable. So as I said before, the shell program is actually another process and it's another application which is already running. So when you're getting ready to type your command, you have to realize that the shell process has already started. We have the shell process running first, and once we hit that enter key, we're going to start running the hello executable that we wrote. Once we hit enter, the shell program is going to honor our request and ask the operating system to transfer control to the hello program from the shell program. So how exactly is this switching going to happen? Well, that's another job of the operating system. In order for the operating system to switch from the shell to the hello program, it has to do this thing called context switching. Right before the OS decides to switch from the shell process to the hello process, it has to save the entire state or context that the shell program was running in, because we're going to have to come back to that later. It then creates a new hello process with a brand new context and gets ready to execute that. There are some setup steps, and we have to tell the processor and some software that we're starting up a new process, and that's going to happen all before we start executing hello. So our hello program is pretty short and it's going to finish pretty quickly. All it does is print out hello, right? So the operating system recognizes that it came from the shell process, so once hello is done, it's going to transfer control back to our shell. Remember how we saved all that context before we switched to hello? That context is just restored, so the shell is exactly in the same place as it was before we started. It's just waiting for you to type more commands and do more things. This whole system of context switching, which happens a lot, just context switching in and out of different processes, takes a lot of work from both hardware and software. They work together to make that happen, and it's all working under the hood for you. Okay, so let's recap real quick. We typed hello and we pressed enter. Remember, a processor can only execute instructions that are in memory first. So one of the first steps we have to do is move our program and all its data from disk into main memory, or RAM. The operating system did a context switch from the shell process to our hello process. It ran the full hello process, we saw our cool text, and we switched back to the shell. And ladies and gentlemen, the whole hello world executable that we wrote has just run in its entirety. Okay, so let's go back to processors a little bit right now. Remember I said processors are always executing instructions in memory. It's always executing. It has this special piece of memory or register which is called a program counter. And almost every single processor has this special program counter. What the program counter really does is point to different instructions in memory. Whatever the program counter is pointing to, the processor will execute that instruction and then update the program counter, and it's going to point to a new one. This is pretty much all the processor does. From the time your computer turns on to the time it turns off, all the processor is doing is exactly executing the machine instructions that the program counter is pointing to. That's all it does. Now, the processor itself is made up of a lot of different hardware components. A lot of different hardware components go into that little square. Now, if you dig really deep into those hardware components, all you'll find is really intricately laid out pieces of metal. And what do you think flows through that metal? Electricity. So pretty much when you write custom software and you're instructing the processor to do different things, you're altering the flow of electricity through those intricate layers of metal. So what I just tried to do is explain how code that you might type turns into electricity that flows through your computer. Oh. Code to electricity? What? Alright, so that was a crazy, like 10,000, 100,000 foot view of the whole life cycle of a program as it runs through your computer. Remember, every single component of this big process that we just talked about, from compilation to context switching to processes thinking they're the only one in the house, they go way deep. So when we're trying to understand big complicated systems like computers, and not only computers, but this goes to like anything in the world, but it's usually too difficult to know every single level of every single process in super detail. It doesn't even have to be related to engineering. But what you're really responsible for is at least being somewhat knowledgeable and having the foundation of knowing what the basics of each level do. You don't have to be a master of every single part of the stack in a computer, but you have to be articulate enough to know at least what its responsibilities are. So not only to computers, you know, there's just to life and stuff. Alright guys, so I'm gonna wrap up the video here. A lot of really big picture ideas, but hopefully it gave you a little taste of what happens when you actually run these programs in your computer. If you have any questions, just leave a comment here and I'll respond. If there's any part of the video that didn't really quite make sense, just ask me. I'll try to make another video or just answer your questions directly. So hope you enjoyed it and have a good rest of the day. Alright? Peace.